Alright, hello and welcome back. My name is Cameron Kirk and this is part 2 on my series of videos on the Apply Python tutorials. It has been some time since I made part 1 and the format of this channel has sort of evolved. And I knew I wanted to continue to expand on this series. And so I think I know the direction I want to take for this tutorial series. Starting with this video, and in today's video, I think it would be a cool idea if we try to learn what a derivative is by programming it using Python. So that is the basic idea of this video. And to give you an idea of what our program might look like when we're all done, I can show you what the finished code produces. I'm going to hit play here. And here is my finished program. Let me change the face cam. So what we have here is an animated plot, and the blue dots is a plotted sine function curve. And really we could change this to any function we want. And then what I've done is I've plotted a line from one dot to another dot. And then we've taken the slope of that produced secant line and we've sort of stretched it out across the entire screen. And then we've animated it as well. And what we're going to see is the derivative is defined as the slope of the curve at a single point. So if I make this bigger, when the dot starts to, you'll see it start to come up this curve and then start coming down. And then when it gets to here, as this dot gets closer and closer to the starting point right here, then the slope of that curve is going to be a very, very, very good, very accurate approximation of the slope at that point. And the closer that dot gets to the starting point, then the more accurate the slope computation will be. So yeah, let's go ahead and get started. I've already started writing some code here. I've imported NumPy. We are going to be using NumPy in this project. I have put a link in the description below for how to get NumPy installed on your Python installation. So go ahead and get that if you don't have that yet. While we're talking about libraries we're going to be using, I am also going to be using matplotlib. Once again, the link in the description. And from matplotlib, we're going to be using pyplot. And if you look around on forums and online, you're going to see people doing this a lot, which is you import a library as, use the keyword as, and that lets you sort of give the library an alias, and that lets you reference it using an alias. So PLT is what I see a lot online, and I'm going to stick with that for what I'm making. This is probably good for now. Oh, that should say from. Okay, this is probably good for now. We're going to be using matplotlib and NumPy. And I've started to write a function definition here, and all this function does is take a variable x and it is going to return the sine of x. Very simple, very straightforward. So let's see what we get if we print f of 0, I guess. We'll start with that. And if I remember from my college days, when sine is 0, sorry, sine of 0 is 1. And then cosine of 0 is 0? Do I have that backwards? I want to say maybe sine of... I'm trying to guess what it is ahead of time. So let's see. My guess is equal to... Oh, that is not how you comment in Python. This is going to be equal to 1. Sine is 0. It's 0. Let's find out. Let's find out. I think it's going to be equal to 0. Ah, man, I forget. It's 0. It's 0! Okay. I'm still a little fuzzy on that, but that's fine. I used to have that memorized. Anyways, not important. Okay, so what happens if we put 3.14 in here? It should be 1. It is not 1. Well, let's keep going for now. That's suspicious. Let's just keep going. Don't worry about it. So let's try to plot this using pyplot. So, or sorry, yeah, pyplot from matplotlib. So let's see. We're gonna do plot is equal to subplot. And we're gonna have only 1. And we're gonna, from this, we're gonna do some tuple unpacking. Okay, so we have our figure, we have our axis, and then we need our x data. So x0 is going to be equal to numpy dot array, no, line space. And let's go from -4 to 4. And then this is where, so it's telling you at the top what each parameter is going to be. So your start point, your stop point, and how many samples do you want to plot over this interval. So let's do 100. And then now y of 0 is going to be equal to f of x of 0. Okay. And then we're going to take the axis dot plot x of 0, y of 0. And then we're going to do plot dot show. Okay, click play. I got an error. Single argument to subplot must be a 3-digit integer, not 1. At what line? Okay, I think I caught my mistake. I think that should say subplots. Let's try that again. Okay, that worked. Yeah, I just had a typo. Sorry about that. Caught me off guard. Okay, so we have our sine wave. And then when we are at 0, it looks like we're at 0. And then, oh, I see now. When we're at 1, we're definitely not back at 0 exactly, but it's getting close. And then 0.5 is when we're at 1, when we're at half. Yeah, I probably should look up the unit circle again. I guess I'm getting rusty. I don't know. Leave me alone, I'm old. Okay, no, just kidding. All right, so now that we know that's working, I do like to see the dots so that we can see how accurate we are. Let me pull that up one more time. So if I zoom in at the top here, you can see it's starting to get jagged. And that is actually, it's connecting the line, or it's connecting the dots for us, but it's actually kind of misleading on the accuracy. So I think we do want to have it plotted as dots and not a line. So in order to change that, under our line that says axis plot, oh, by the way, I scooted everything over this way so that you can see the whole terminal that's being printed out with me. So as we're kind of going along, you can read the error that I'm reading. Because we are going to get errors. It's going to happen when you're doing this kind of live coding. Not really going off of the script. So I believe this is all you have to do to say use dots. So let me try that. Click play. Yep, that's all you have to do. You put quotation marks, you put a string that has a period. Great. So just to have some fun, let's do 1,000 samples between these 2 points. And you can see it looks like it drew a line again, but then if I get the magnifying glass and I zoom in on a section, you can see that they are all just dots plotted on a point. Okay, let's close that down. So this is looking pretty good. We already have the sine wave plotted, and we made our sine function, and we printed out some values from that sine function. So this is looking all right. Yeah, so the whole point of this is to calculate in order to make a derivative. Sorry, I just had to read my notes to make sure I wasn't forgetting something before we move on to this next step. I'm going to turn that back down to 100 just because I don't think we need that many points plotted. If you want to follow along and use a different number of samples being plotted on your line space, feel free to do so. But I'm going to stick to 100 because it's easier to look at and troubleshoot any bugs. Why can't I push play? There it goes. Okay, so in order to make a derivative, the derivative is defined as the slope at a point on the curve. So the whole thing is our curve. We have to pick a point. So it doesn't really matter what point we pick. We just pick a point, and then we want to get the slope at that point. And the slope is basically a line that comes through and just barely touches our point. So let me click home here. So feel free to pick any point you want. I'm actually going to mark my point on the graph by just plotting a dot on there. So let's see if we can do that. I am going to say we're going to make a new variable. I'm going to call this x_start. That's going to be equal to from x0. This is going to be, I don't know, number 62. So I'm accessing the line space array at x0, and I'm setting xstart equal to that. And then I'll call this ystart, and this is going to be from y0 at index position 62. Let's see if we can get that to show up. So x-axis plot, and then we're going to do xstart, ystart, save, and it should be a different color automatically. Hit play, see if that worked. Yep, I can see it right there. That one's an orange dot. And just to make this easier to look at, we can probably increase the size by typing a comma. And if I start typing size, I guess. Size? Nope, that's not it. Marker size is equal to 12. So we want marker size equal to 12. So now when I hit play, there we go. We got a nice big orange dot. That's, yeah, you can see that. Let me make sure that, yeah, you should be able to see that. Yeah, you can see that. Okay, cool. So I'm going to be working with 62. You can work with whatever point you want. If later on we may allow the user to pick any point and get the slope at that curve. Great. So what we need is a function that can calculate slope. So we do need to know the formula for slope. This is like algebra level, right? Algebra 1, or not sure what grade you might learn about slope, but I'm going to call this function slope. And what do we need to calculate slope? Well, we need rise over run, right? Slope is rise over run. And at least that's what I was taught in school, to remember the formula for slope. If you also know the equation of a linear line, it's equal to y is equal to m times x plus b. I wonder if I need to make this font size. No, that font size is plenty big. You should be able to see that. And m is the slope. M is the slope, and that is equal to y2 minus y1 divided by x2 minus x1. And a lot of the times you might hear people say x2 is equal to final, x1 is equal to initial. Same thing with y. So x2 is end and x1 is start. And that's what you use to calculate slope. But what you're noticing here is it's saying y2 and y1. So that's two different positions on the y-axis, and x2 and x1 is two different positions on the x-axis. So what that's saying is you need 2 points. You need 2 points to calculate the slope. Oh, it's not going to let me hit play because I have a invalid function definition here. Oops. All right. Let's just do return. Hit play. So in order to compute slope, you need 2 points. You need a x2, y2, and you need an x1, y1. So a final position and an initial position. So this will be our initial position, and this will be our final position. And we want to find the slope of the straight line between these 2 points. Okay. So because we know this formula requires 2 points, we're going to do P1, so for point number 1, and P2 for point number 2. All right, I'm going to kind of move all of our other code down, and then we're going to return basically this formula. This is pretty much our formula. Okay, and I'm going to show you a little bit of an advanced Python technique, but it is very helpful to know about. It's called tuple unpacking. I'm going to put a comment here so you can look it up if you are interested to read more. Tuple unpacking. And what's going on here is we need to unpack our coordinates from the points. So we're going to have an x1 and a y1, and it's coming out of P1. And Python is smart enough to see, okay, you want to unpack 2 variables from a variable, then this guy must be a tuple, and I will unpack it. And that's pretty much the whole idea. So x2, y2, p2. Okay? And so down here, we're going to say start is equal to... we need an XY pair, so I'll do 1, 2, I guess. Oops. I guess I clicked something. And then end. Yeah, I'll call it end. It's going to be equal to a tuple. So tuples are written like this. You just put parentheses and then separate the values by commas. Our end will be 6, 9. And then we're going to print the slope. So we're going to use the print function. We're going to use our slope function we just defined. Oh, I keep hitting something. Sorry about that. Slope. And then we're going to pass it start point and end point. And we'll hit play. We'll let that load. Nice, and it printed out 1.4. I'm going to close down the graph since we're not using it. It printed out 1.4, and so I am guessing that is the correct answer. I'm going to pause the video and punch it into the calculator and see if I get the same answer. Okay, so I got it in the calculator. You can see the equation there. I'll hit equal, and it's 1.4. Cool. So now we have a function that we can give it 2 points, and it will magically give us the slope of the line that connects those 2 points. Very good. So what we're going to do next is we are going to try to add our animated secant line. So I'm going to take off these lines of code here. We're done with that. We know that our slope works. Okay. So in order to get the animated plot, we actually need to import another library. So from matplotlib.animation imports function animation. Okay. And since this is an animation, it actually needs a couple of functions in order for it to work. It needs an initialization function, and I'm going to leave that like that for now. And it needs an animate function with a parameter I, or function argument I. And for now, I'm just going to return. So we need these two functions. This is going to set up our initial data, and then this is going to actually update the values on each frame of the animation. So now that we have those two functions ready to be defined, we also need to create our lines. So this is going to be a line object. We're going to set this equal to, and this is a variable name. You can name this whatever you want. I'm going to call mine line object. This is going to be equal to axis.plot. And then I'm going to give it empty square brackets, and then we can give it a line width. I'm going to give it a line width of 1, and that's probably good for now. Yes, we're good with that for now. So now, let's see. Underneath these guys, we're going to have a new animation. I'm going to call this animation. That's a variable name. And it's going to be equal to function animation. And we're going to pass it our figure. So that's from the results of this call here. We're going to pass it the name of our animator function. And in this case, our function name is called animate. We're going to pass it our init function. So init underscore func is equal to init. So this is just the name of the function that does our init. And we're going to, what did I do? And we are going to pass it a frame rate, or sorry, a total number of frames. So we're going to do 100 frames in this animation. We're going to pass it a frame rate, which is interval. And I'm going to call it 200 as a starting value, but you can play with that later. And then we're going to give it split, which is body line iterator. We're going to set that equal to true. All right. So basically, this line of code, he is going to call our animate function, and he's going to call the init function. And the animate function is going to take I, which is the frame number that we're on, and it's going to recalculate the values that need to be plotted and pass that back to the func animation function to then plot it on the screen. So let's start off with the init function. This init function needs to take our line object and it needs to set the data to empty and then it needs to return that line object. Save that. All right, and then for the animate function, this is where we are going to plot our secant line. So to do this, we are going to take our, let's see, we need 2 points. So we need an x2. Let's call it x end. And this is going to be from the NumPy. This is going to be a line space, but it's going to be consisting of only 2 points. So our start is going to be from x0, 62. Our stop is going to be at, and this is the one that's going to iterate over various indices. So we could do, I don't know, to 80, but then we're going to subtract I from it. And each time I comes in, he's going to decrement from 80. And so it's going to start counting down. But one thing that we have to take into account is when it gets to 0, we actually want it to wrap back around. So a fun little way of getting a loop to happen like that mathematically is by using the modulus operator. And we're going to mod 100. So if you've never seen the modulus operator, the best way to explain it is if I get out, I guess, Paint. Let's see how quickly I can explain this. I don't want to make this video too long, so I don't want to spend too much time here, but it is worth explaining. Okay, so let's get the brush size nice and big. Okay, so if we had 3 into 20, I guess. This goes into 26 times. And that's going to be minus 18. And 2. Okay, and then you could go into the decimal, but I'm going to say no. We're going to have a remainder of 2. And 3 goes into 26 times with 2 left over. So that's our divisor. So if we wrote this in Python, if we did 20 divided by 3, that's going to give us the divisor. And if we did 20 modulus 3, that's going to give us the remainder. So this is a operator that gives us exactly the remainder. It doesn't give us this answer up here, the divisor. It doesn't give us 6. It gives us this other bit of information too. Because in the world of integers, when you don't get decimal numbers, and you do division, you actually get 2 results out of the division operation. You get the divisor and the remainder. Okay, hopefully that makes sense. So the reason why this is sort of a loop is if you consider what are the possible remainders you could ever have when dividing any number. Let's do a different color. Any number, you divide any number by 3, what are the possible numbers you can get? Well, we could have a remainder of 0. Yes. We could have a remainder of 1. Yes, there could be 1 left over. A remainder of 2, yes. Can we have a remainder of 3 ever? Ever, ever? And the answer is no. You can never have a remainder of 3. If you had a remainder of 3, you did your division wrong, because you're supposed to say how many times 3 can go into it, and if you have 3 left over, well, your job's not done. You need to take those 3 and you need to count them in your divisor, and you need to set the remainder to 0, right? And so what did we get? We basically have this mathematical definition of a loop. Little bit of a stretch, a little bit of a mind bend, but that's how it works. So, I wonder why I'm using so much GPU. Oh, I think I put it back to 1080p, I think. I hope I'm not doing this in 4K. That would be too much resolution. Well, it's too late now. Let's push through and try to finish this out. Hopefully this video comes out okay. Don't save. Okay. So by putting modulus 100, we're saying when you get to the 100th point, you need to loop back around. You don't, you don't keep counting down. All right. And then the final argument is to say 2 points. We don't want a sample of 50 points. We want 2 points in our sample size. All right, and then same thing for our y end. This will be our y end, but instead of x, we're going to say y. Yeah, and that's pretty much it here. Now we need our start point. And to get the start point, we're going to say x1. Sorry, let's do x start. This is equal to numpy dot line space. Well, basically it's going to be equal to x0. So, but we don't want to say equal x0 because we want to make sure we get a full copy for x start. We don't want a shallow copy referencing x0. I can't get into that in this video, but just take a look online for Python array shallow copy versus deep copy. I'll save that for another video to explain how that works. All right, and then our y start is going to be equal to. Now, in order to get our starting position of our x1 and our y1, this is actually going to be using the equation of a line, which I had written out up here, mx plus b. So our m is going to be our slope, and our slope is coming from our x2. So this is our x2. This is basically our So this is basically our small secant line, and then what we're doing now is we're stretching it out. I probably mislabeled these. Let's just call this x2. Let's call this x2, and we will get into this code in the next video. I just want to wrap this up so I can fix my capture settings. Yeah, so then we're going to say line object dot set underscore data, and we're going to give it our x2 and our y2, and then we're going to return that. Save it. Okay, hopefully I did this right. Let's hit play. If this is working, then I can shut the recording down and fix my settings. And it's not working. Darn it. Oh, I put out a message in the log. All right, let's fix this. And then we can move on. Dun, dun, dun. List has no attributes set data. List has no attributes set data. Okay, let me pause. Hold on. Okay, so I think I caught the mistake. So since we're doing subplots and I put 1 here, there's the potential for there to be more plots. And so we need to tell it we want the first item from axis plot. I think that will fix it. Yes. So you just put square brackets 0. So axis, the first guy in here. Actually, I don't think that's the reason why. I think it's actually gonna, let's look at the, what does it return? We're recording, right? Okay. It's gonna return, yeah, it's gonna return a list of 2D lines. And we want the first one on that list. Where does it? Returns a list of 2D lines. So we're gonna get the first 2D line on that list of 2D lines by putting square brackets here. So that should fix the problem. So let me hit play, see if it works, and then I can fix my capture settings. Because it keeps giving me this encoding overload error on my OBS. And I'm hoping this video is still usable. Darn it! Okay, so line 2D object is not iterable. All right, let me pause the recording. Okay, so I found the problem. If you have this BLIT equal to true, it's expecting there to be multiple lines to update and plot. So we can take that off, or we can set it to false. We are going to add more lines later, so I recommend just setting it to false so we don't forget about it. At least that's what I'm going to do. Once you do that and you hit play, everything's all fixed up. And we're good. Oh, come on. Can you open? There it goes. Yep, so now we have this nice animated graph. Ooh, it's going slow. All right, and it is hitting all of the, it looks like it's going every other point actually. I will have to look into that in the next one. Anyways, hope you enjoyed this video. I'm going to cut it short here so I can fix my settings, and we'll pick it up in the next one. Take care. See you in the next one. Bye-bye.